Good morning, students. Today is the class number 14. The last time I had discussed some problems on composition. So same problems will continue today. If f from R to R, g from R to R, we define by f of x is x square plus 2x plus 1, g of x is 3x minus 2. Find f composition g composition f, and g composition g. Now what is given? F of x is equal to x square plus 2x plus 1 and g of x is equal to 3x minus 2. The first question, f composition g is same as f composition g of x, f into g of x, f into g of x, f into g of x value 3x minus 2. Now wherever x is there, substituting 3x minus 2, 3x minus 2 whole square, 2 into 3x minus 2 plus 1 equal to 9x square plus 4 minus 12x, 3 to 6, 6 to the 12 plus 6x minus 4 plus 1, 9x square minus 12x plus 6 minus 6x and plus 1. So this is f composition g. Then what is f composition g? Nothing but f into g of x. It is a function of x. F bracket of g of x. F of 3x minus 2. So 3x minus 2 square plus 2 into 3x minus 2 plus 1. So substituting. So this is the answer. And second problem. G composition f is same as g composition of f of x. It is a function of x. If it is not given, function of x only. G into f of x. G of, what is f of x? X square plus 2x plus 1. So what is g of x? 3x minus 2. Wherever x is there, x square plus 2x. 3 into x square plus 2x plus 1, 3x minus 2, 3x square plus 6x plus 3 minus 2, 3x square plus 6x plus 2. This is the g composition here. G composition, g into f of x, g into f of x, composition definition. Substituting f of x square plus 2x plus 1, just to assume this is x only, you read g of x 3x minus 2, replacing x by x square plus 2x plus 3x minus 2. So this is the final answer. And what is the third one? G composition g. G composition g of x. G of x. G of, what is g of x? 3x minus 2. G of x 3x minus 2. Now g of 3x minus 2 is wherever x is there, 3 into 3x minus 2. 3 into 3x minus 2 minus 2. 9x minus 6 minus 2. So 9x minus 8. So in the question, sometimes it is asking 3 marks question. There are 3 steps are there. You will have to calculate f composition g, g composition f, and g composition g. Maybe it is we are expecting 3 marks question because the 3 results are there. Every result is 1 marks. And next problem. if f from R to R and G from R to R are defined by f of x is equal to root x and g of x is equal to x square. Find f composition G of 4 and G composition of 3. Find f composition G of 4 and G composition f of 3. Now here already it is x value given, that 4 and 3. Okay, what is the given? F of x is equal to root x and G of x is equal to x square. The first problem, f composition G of 4, f of G of 4, f of what is G of x square, G of 4 square. So f of 16, f of x root x, f of 16 root 16. So root 16 is 4. This is one. And second problem, G composition f of 3, G of f of 3, G of what is f of 3? F of 3 root 3, because f of x is root x. What is G of x? X square. This is root 3 square. This is equal to. So first question, G f composition f is 4, G composition f of is 3. Problems are not difficult, so it's very simple. Just you have to replace the x. Okay. Next problem. If we have from R to R, defined by f of x is equal to x cube. Find f inverse of 8 and f inverse of minus 64. Now what is the given? The mapping up from R to R, f of x is x cube and f inverse of 8 and f inverse of minus 64. But here positive 8 and here negative. Right, solution given f of x is equal to x cube. Let f inverse of 8 equal to, I am taking x because I want f inverse of 8. What is f inverse of 8? F of x is equal to 8. X cube equal to 8. And most of students are taking x cube is 8, x cube is 2, cube x is 2. That 100% x is 2 is correct. But how many roots are possible? 3 roots are there, because cubic equation it must be a 3 roots. And usually students are taking x cube is 2 cube, x is power same base is equating. That 100% 2 is correct. Out of 3, 2 is a 1 root. So what is the another 2 roots? That very important. This is cube roots. So cube roots always 3 roots. One real roots and 2 imaginary roots. So what is the x value? First one is 2. Another is 2 omega. Another is 2 omegas. It's very, very important. So instead of 8, 1 is there. 1 omega square. 1 omega, one value of omega square are there. Omega value minus 1 plus I root 3 by 2. What is omega square? Minus 1 minus I root 3 by 2. It comes in complex number only. In complex numbers, cube roots of unity. So what is omega? Minus 1 plus I root 3 by 2. Now minus 1 minus r, these two are conjugate to each other. Okay. So here 8 if I go 2 omega, just multiplying these 3 becomes 8 only, because omega cube is 1. So this is the what is the question is f from R to R. F from R to is only real numbers. Therefore x value is 2. X value f inverse of 8. F inverse of 8 equal to 2. Why these two are not possible? Because the mapping from R to R. And between this mapping from R to R, C to C I am taking complex to complex. When you are taking C to C, all the 3 possibles, because every real number is a complex number. This is also complex number only. Okay? So when R to R, only one answer, and when C to C is given, all 3 are possibilities. Okay? This is the important question. He is asking find f inverse of 8. So what is the second problem? Second problem is f inverse of minus 64. Let f inverse of minus 64 equal to x. Therefore f of x is equal to minus 64. If x cube equal to minus 64. Now negative is there. Therefore x is equal to minus 4 omega minus 4 omega square. And multiplying all the 3, then minus 64 only. But here also is mapping R to R. Therefore x is equal to minus 4. F inverse of minus 64 is equal to minus, because mapping from R to R, real number to real number. When real to real, when C to C means minus 4 omega, minus 4 omega square. And next problem, if f from R to R, if f from R to R defined by f of x equal to 3 minus x cube 4 raised to 1 by 3. 3 minus x cube 4 raised to 1 by 3. Then find f of composition f of x. F of composition f of x. Right, solution. Given you read carefully. F of x is equal to 3 minus x cube 4 raised to 1 by 3. Now what is the question? F of composition f of x is equal to f into f of x. F into what is f of x? 3 minus x cube 4 raised to 1 by 3. Okay? Now I am taking letters 3 minus x cube 4 raised to 1 by 3. And I am taking z only. When taking z means it comes f of z only. Complete of taking. This is z. This is I am taking z. Now it is f of z. What is f of x? 3 minus x cube whole raised to 1 by 3. F of z 3 minus z cube whole raised to 1 by 3. 3 minus z cube. Rising the power 3, 3 cancel. 3 minus z cube 4 raised to 1 by 3. I'll repeat once again. F of z is 3 minus z cube whole raised to 1 by 3. So what is z you know? 3 minus x cube whole raised to 1 by 3. 3 minus, what is z? 3 minus x cube whole raised to, what is z? Z value 3 minus x cube. Z cube means rising the power 3, 3 cancel, 3 minus x whole Don't confuse it. F of z 3 minus z cube over to 1 by 3 according to function f of x. So very important, this step I am taking directly. Z cube will 3 minus x cube only, 3 minus x cube. So 3 cancel plus x cube plus x cube over raised to 1 by 3. F2 composition f of x is equal to x. So you know this is in previous class I explained. F composition f of x is x. This is called identity function. What is called identity function? The inverse of f is f inverse only. So f inverse is f in this case. Sometimes this problem, what is the inverseness? That is whatever the given function is inverse only. F inverse is f. When you are taking f inverse, it must be identity function. Composition f of x is x. Next some properties or theorems are there. Show that it is very important. Show that almost the composition properties are almost same only. Okay. Show that if f from A to B and G from B to C, f from A to B and G from B to C are 1 1 so that if f from A to B and G from B to C are 1 1, then G composition f from A to C is also 1 1. This is most important. Theorems one side I am doing. The 5 theorems are there in function. So this is a very important. Sometimes we are asking to, maybe it is 3 marks question only. If f from A to B and G from B to C are these two are 1 1 functions, then composition is also 1 1 function. In C it is without solving, you get direct answer on that. Both are 1 1. G composition also 1 1. Right through. Given f and G are 1 1 functions. 1 1 functions. Given f and G are 1 1 functions. Both are given functions. To prove that G composition f is 1 1. G composition f is 1 1. Now G composition f of x1 equal to G composition of x2 for all x1 comma x2 belongs to set D. Now consider G composition f of x1 equal to G composition f of x2. We have to prove x1 equal to x2. You consider these two, we have to prove x1 equal to the composition also 1 1. Given f and g are 1 1 functions and composition you have 1 1. Now G composition f of x1 equal to G composition f of x2 for all x1 and x2 belongs to A. It implies G of f of x1 equal to G of f of x2. It implies f of x1 equal to f of x2 because G is 1 1. It is given. Both f and g are 1 1 function. You have to prove composition 1 1. Because why you are removing this g? Because 1 1 function. G is given. G is 1 1. It implies x1 equal to x2 because f is 1. F is 1. F is 1. Now you got fx here. x1 equal to x2 is 1. Hence, G composition here is also 1. Because G composition f of x1 equal to G composition you have to x1 equal to x2. It is G composition of 1. So very important theorem. Tell me what is the theorem statement. Even f and g are both are 1 functions and always composition is 1. So how to prove? You consider G composition f of x1 equal to G composition f of x2 and using composition property, and now removing G is 1 and next f you removing, f is 1. Now finally x1 equal to x2. When x1 equal to x2 you know that 1 function only. So here G composition f is 1. Next, theorem 2. Prove that if f from A to B and G from B to C are onto, then G composition f from A to C is also on. Very important definition, theorem. Both are onto, then composition from A to C is also on. Proof. So very simple. So what is given? Given f and g are onto functions. Onto functions. So this is f, this is the G, A, B and C. This is the B, okay? So I am taking some Z elements, Y elements, X elements. When you got Z equal to X or X equal to Z, definitely is called onto. You have to prove X equal to Z, this is equal to this, okay? That is called onto. So how to prove that? So very simple, I am explaining. G is onto, because G is onto, both are F and G are onto only. G onto, there exists this element such that for every Z belongs to C, there exists Y belongs to what? G. F, G of Y is Z. For every Z belongs to B, there exists Y belongs to B, such that G of Y is Z. Then one equation. Another, F is also it is onto. For every Y belongs to B, there exists X belongs to A. Then F of X equal to Y. Now using both equations, definitely comes G composition F is 1. Then onto. So let Z belongs to C be any element. Since G is on. Since G from B to C is on. For every Z belongs to C, there exists Y belongs to B, such that G of y equal to z. We call equation 1. Since g from B to C is onto, for every z belongs to C, there exists y belongs to B such that g composition y is z. Also, since f from what A to B is onto, for every y belongs to B, there exists x belongs to A. Onto definition of taking such that f of x is equal to y. Equation number 2. This is onto, g is onto, here f is onto. What to prove? The composition. We have to prove that composition is onto. Okay? So from equation 1, g of y equal to z. From 1 using wherever y is f of x, g of y is f of x equal to z. You know what this is? G composition f equal to z. So G composition of x equal to z. What is the meaning? G composition f of x is z. What is the meaning? For every z belongs to C, there exists free image under G composition f. Okay? So for every, it means that for every z belongs to C, then there exists its free image under G composition A. For every z belongs to C, then there exists its free image under G composition A. Hence G composition F is also very important. If it is both 1 1 and f is 1 1 and the function f is 1 1, the function f and g are 1 1, composition 1 1. The function f and g are both are on, composition also on. These two are very important property. So very important just in practice. So what is the last step? G composition f of x is z. G composition f of x is z, it means that every element z belongs to C, then there exists its free image under G composition f. So hence G composition f is on. So what is the next theorem 3? Theorem number 3. Let f from x to y. Let f from x to y be an invertible. Be an invertible function. Let f from x to y is invertible function. Show that unique inverse. Suppose you are taking G1, G2 are two inverses. You have to prove G1 equal to G2. You are taking Y1, Y2 are two inverses. Y1 equal to Y2. You are taking Z1, Z2 two inverses. Z1 equal to Z2. You are taking X1, X2 two inverses. You have to prove X1 equal to X2. Okay? So very simple definitions here. Given f from x to y, it is not small, it is capital. Be an invertible function, show that it pays. What is given? Given f from x to y. Given f from x to y is invertible. The function f from x to y is invertible means that is f is 1, 1 and R2. F is 1, 1 and 1. The function f from x to y is invertible. It implies f is 1, 1 and 1. That is f inverse is exist. Now it is inverse exist. So inverse does not exist. There are no unique inverses. Okay. When you say the unique inverse, inverse must be exist. When it is inverse must be exist, it must be 1, 1 and 2. The function f is 1, 1 and 2. That inverse also 1, 1 and 2. It's f is invertible. F is also invertible. F from x to y is invertible. Invertible meaning f is 1, 1 and 2. When f is 1, 1, inverse is exist. Suppose f is not 1, 1 and 2, inverse does not exist. Okay? When f inverse exists, when you got f inverse exists, that you have to prove unique inverse. But you prove unique inverse. Unique inverse. When inverse exists, you have to prove unique inverse. Okay? So how to prove? Now, G composition f equal to f composition G. This is identity. G composition is equal to G composition f y1 equal to, or simply y, not y. F composition, sorry. Okay. And before, one important. Now, f inverse exists means, let us assume that G1 and G2 be two inverses of f. Be two inverses of f. These two are inverses of f. This term is G of f composition G1 equal to f composition G2 equal to R. Suppose you want a function of x, function of y. I am taking y. F composition G of 1, f composition G of 1 equal to I. Now, and small y belongs to only I am taking f composition G1, but it is a function of y because y belongs to 4 domain. Okay, it implies f into G1 of y, f into G2 of y. You take these two. I'll repeat it once again. Given f from x to y is what? Invertible. Very simple. F from x to y is invertible means what? F is 1, 1 or 2. F is 1, 1 or 2 means f inverse exists or does not exist. When f inverse exists means your theorem is we have to prove unique inverse. When f inverse exists means after exist only have to prove unique. But how to prove? You consider two inverses. That G1, G2 be two inverse of f. When two inverse of f, what is the relation? F composition G1 equal to F composition G2 equal to I. What is G1, G2? Be two inverses of f. Now consider f into g1 of. You can take these two. You can take these two, both are equal. So f into g1 of y. Otherwise you take and now f composition g1 of y equal to f composition g2 of y. It implies f into g1 of y equal to f into g2 of y. So it implies g1 of y equal to g2 of y because f is what? 1. F is 1. Therefore, it implies g1 equal to g2. What is g1 g2? Please tell me. Yes, g1 g2 are the inverses of f. So I am clear. Suppose some students have z1 and z2 b2, z1 equal to z2 will get. And some students have y1 y1 equal to y2. But whatever you take g1 g2 it becomes g1 g2. So g1 equal to g2. Okay? Hence, what? The function f is, hence, the function f has uniqueness. Okay? No repeating. It has uniqueness. Only one inverse exists. This is the important property. Next theorem. Next theorem. Let f from x to y be an invertible function. Show that the inverse of f is inverse of f inverse. So that inverse of f inverse is f. That is f inverse of inverse equal to f. Very important property. Let f from x to y be an invertible function, so that inverse of f inverse, 2 times inverse, is answer f. So g inverse of f, 2 times inverse लिखे इसको same आता function. So inverse of inverse is itself only. So how to prove it? It's very simple, but this is not 3 marks. It is sufficient. 2 marks question, very important, and very important. You have to practice many times. Okay. What is given? What is given? Please tell me. What you prove? F inverse of inverse. Okay, f inverse of inverse. Now what is given? Very simple. F from x to y. Given f from x to y is invertible. Invertible means what? It implies f is 1, 1 and R2. When 1 R2 means, therefore f inverse is given f from x to y be invertible function. Given f from x to y is invertible means f is 1, 1 and R2. F is 1 1 and 2 means F inverse is exists. Also, very important, also F inverse is both 1 1 and 2. That is, F inverse is invertible. F inverse of inverse is exist. Very simple. F is 1 1 and 2, F inverse exist. Also, F inverse is both 1 1 and 2. It is bisection. When F inverse is both 1 1, F inverse is invertible. F inverse of inverse is exist. It implies F inverse of inverse equal to F inverse of inverse is exist is nothing but F inverse of inverse is F. Hence proved. Hence the function F from xy invertible. The inverse of F inverse is F. Okay? I'll repeat once again. Very simple there. Only that practice. Okay? Given F from A to B or x to y, F from xy is invertible. F is 1 1 and R2. F inverse is exists. Also, F inverse is 1 1 and R2. F inverse means it must be 1 1 R2 only. F inverse is both 1 1 2. It's bijection. When F inverse both 1, F inverse is invertible. When F inverse is invertible, F inverse of inverse is exist. When F inverse of inverse is exist, means F inverse of inverse is F. So this is the property number 4. Even some property of composition. Okay. Last period, we discussed some composition property also happened. Now, what is property 4? Okay. This is also very important. Let F2 from x to y. I know G from y to z. B2 invertible functions. B2 invertible functions. B2 invertible functions. B2 invertible functions. Then G composition F is also invertible. With the G composition F inverse equal to F inverse composition G inverse. Yes. When G composition F is invertible, we have to prove G composition F inverse equal to F inverse components. Now this is called reversal law. It is called even in matrices also it comes AB whole inverse equal to B inverse into A inverse. You take any two matrices AB, then AB whole inverse equal to B inverse into A inverse. Alright. Now it is same. G composition F inverse equal to F inverse composition. Not only when you take one more function, it's reverse it that way. Okay? So very important. We have to prove this is the inverse of this. Okay? So also G composition F is invertible. G composition F invertible with the G composition F inverse is F inverse into G inverse. So slowly I am explaining. This is also maybe 3 marks question. Okay? You will sometimes simply prove that G composition F inverse equal to F inverse composition. Now proof. Very simple. Now consider G composition F composition F inverse composition G inverse. When these two are multiplying, now it must be identity function. When identity function is inverse, this is the inverse of this. It must be identity. It must be a. So when B equal to, suppose the AB is I. Suppose AB is multiplying these two matrices, any one is the inverse. If it is given A, B is A inverse. Given B, A inverse is B. Okay? Both are possible. Now here we have to prove identity. Now A, B, C, associative property. A, B into C. You are assuming this A, this B, this C. A into B, C is there. Now we have to write A, B into C. What is A? G composition here. Composition here inverse. Composition G inverse. Be careful. This is now present A into B, C is there. Now I will write A, B into C. So A, B, this is A, B, C. A, B into C equal to. Now associative property. G composition, F composition, F inverse. Composition G inverse because associative now. What are associative? This one. There are associative how many elements theorems? 1, 2, 3. Associative. G composition, F composition, F inverse is I. Composition G inverse. Because by definition of inverse. By definition of inverse. G composition I is G. Composition G inverse. Because by definition of identity. By definition of identity. Now it becomes identity. By definition of what? Inverse. Now what is this? Final answer. This is what identity. G composition here. Composition F inverse composition G inverse equal to equation 1. Again, F inverse composition G inverse composition G composition F. This is AB into C. So you have to A into B C. F inverse composition G inverse composition G composition F. Same as property here also. F inverse of using associative G inverse composition G composition F because associative F inverse of composition, this is called I composition F because by identity, by not identity, by inverse. F inverse of composition, this is nothing but F because by identity. Now it is equal to R because by definition of inverse. Definition of inverse. Hence, F inverse composition G inverse composition G composition F equal to R. Equation 2. From 1 and 2, from 192, from 192, G composition F inverse composition G inverse equal to F inverse composition G inverse composition G composition F equal to, from equation 192, from 192, both are identity only. This is AB, that is called a B. Both AB and BA equal to 1. Now what is this is? This is the inverse of. What is G composition here? Here F inverse composition G inverse is the inverse of G composition. F inverse composition G inverse is the inverse of G composition. That is, G composition of inverse equal to F inverse composition G inverse. This is the important. I'll repeat once again. So first we will prove this identity, second also identity. What is this is? What is this is? This is the inverse of this. This is the inverse of, or inverse of G composition F is this. So G composition F is invertible with G composition F inverse. What is this is? Meaning G composition F is invertible. G composition F is invertible with G composition F inverse equal to F inverse into F inverse composition G inverse. So this is, but in previous year we not asked this there. Maybe next day expecting the 3 marks question. Simply sometime without composition also asking G into F equal to F inverse into. But this is not correct. So usually in functions they are using composition. Okay? Repeat last step. We have to prove these two equal to identity. What is this is? G composition F is invertible. This is invertible with G composition F equal to F